Hey everyone! Today we're going to be doing a specific heat capacity question where we're going to be solving the final temperature of a heated substance. In these types of questions, we're going to be heating up a substance only, taking something that was cooler and making it warmer. We're not going to be boiling it, or melting it, reacting it, or lighting it on fire. Cold substance becomes warm substance. So let's give it a go. As we read this question, we're going to highlight the key points. A 56.5 gram sample of glass has a specific heat capacity of 0.84 joules per gram degree Celsius. This glass is important because it tells us that this has to be the specific heat capacity. If that value is not provided in the question, you're going to have to find that in a table, either somewhere in your textbook or you're going to have to find it in a table online. Calculate the final temperature, so we're looking for temperature final, of the sample if it began, this is our temperature initial, at 42.6 degrees Celsius, temperature initial, and had 769 joules of heat applied. The equation that we're going to use for this is Q equals mc delta T. And since we're looking for our temperature final, we can actually rewrite that out as Q equals mc temperature final minus temperature initial. Let's go ahead and fill in what we know. We know what Q is. That's our energy. So we have 769 equals M. That's our mass, 56.5, multiplied by C, our specific heat capacity, 0.84, multiplied by, temperature final. We don't know that yet. Subtract our temperature initial, 42.6. If you've gotten this far, you've completed the chemistry portion of this. All that's left is algebra. So let's go ahead and algebra this up, and we're just going to clean this up by dividing it out. So we're going to divide this side by the 56.5 and the 0.84, and we're going to do the exact same thing to this side, divide it by 56.5 and the 0.84, and that's going to leave us with a 16.2 is equal to temperature final minus 42.6. And we want to get this temperature final all by itself. To get rid of this negative 42.6, we are going to add 42.6, add 42.6, and we are left with a temperature final equal to 58.8 degrees Celsius. And that will be the final temperature of our glass from this problem. Let's go ahead and try another one. We're just going to move down here, and I already got one ready. Again, we're going to highlight key information. Determine the final temperature of a sample of copper. Once we've identified the sample, we're going to use that to get our specific heat capacity. In this question, I've provided you with that specific heat capacity of 0.385 joules per gram degree Celsius. If that value is not in your question, again, you're going to have to find that in a table, either in your book or you're going to have to find it online. When 846 joules are applied, that's our Q, the sample has a mass of 125.4 grams and an initial temperature of 39.8 degrees Celsius. We have all of the information that we need. Let's go ahead and fill this in. We have Q equals mc temperature final minus temperature initial. We can fill in what we know. Our Q value is 846 equals our mass, which is 125.4, multiplied by our specific heat capacity, which is 0.385. Once again, this is multiplied by the temperature final that we don't know, subtracting our temperature initial, which is 39.8 degrees. Again, if you've been able to read this question, highlight the key pieces of information, and fill it into the equation, chemistry is complete. It's time for math. So let's go ahead and do some algebra here. We are just going to divide this out. We're going to get rid of all of these coefficients in front so that we can get this temperature final all by itself, which means dividing by 125.4 and dividing by the 0.385 on both sides, 125.4 and the 0.385, that's going to leave us with 17.5. Take this 846 and you divide it out. It leaves you with 17.5. On this side, that all cancels. It leaves us with temperature final minus 39.8 degrees. Oh, we're almost there. We add 39.8 to this side. We add 39.8 to this side. And hooray, our temperature final is equal to 57.3 degrees Celsius. And I box my answer because that makes me happy. And that's how we use specific heat capacity to solve the final temperature of a substance that we've heated up. Cheers!